Okay. It's not necessary to change. Survival is not mandatory. So this quote from Edward Deming, he talks about change, and I think it's all about change today. The world is changing faster and faster, and nothing is static. The constant today is the change. And Deming talks also about survival. So if we want to survive, we need to change. And Agile provides us with a possibility to adapt to changes to customer needs very, very fast. Okay. But the world has never moved that fast, and it will never ever move that slowly again. So only 12% of the Fortune 500 companies from 1955 were still there last year. So only 12% of the companies survived. And we don't want to be the ones that are not adapting fast enough for the marketplace. They don't keep up with the speed of the marketplace. We don't want to be the ones that didn't survive. And Kanban can help us to be fit for purpose also for tomorrow's world. With these words, welcome to my talk, Kanban Airbus, Evolutionary Change. My name is Bernd Vögele. I'm working at Airbus since about 15 years. I think it's a little bit more now already. I worked in several projects and in a variety of roles. There, starting as a software developer, then moved quite fast to a software architect, and also these traditional roles like a software development lead. And when we were switching to Scrum, I also worked as a Scrum Master and a product owner, but also more traditional roles, management-like roles like a technical project manager. And nowadays I also work as Agile coach and as a Kanban trainer. To give you a little bit more insight about what we're doing at Airbus, and what I want to talk about is, I will give you a little bit of insight. This is the wow. It normally has other dimensions, so I wonder a little bit. This is the A400M. The A400M is a military transport aircraft. In Germany, it will replace, for example, the very old Transall, but it's delivered to several nations. So, for example, France, Spain, UK, Germany, Belgium, Turkey, and also Malaysia, which I like very much. And the A400M is assembled in different nations. Also, we built it together with our colleagues in France and Spain. And the part we are doing from the A400M, to come to a point, is we are building the ground support system for the A400M. So it's running on a military basis, and it's software that supports on ground the complete mission of an aircraft, so the complete logistical and tactical missions. You can plan, for example, a mission, prepare all the data, the maps, navigational data, and so on, and upload it to the aircraft. And on ground, you can also do a 2D and 3D mission rehearsal to check if you want to fly the mission that way. And later on, you can download this data and then do a debrief of your mission. For example, what was the mission like it was planned, and you can compare flown and planned data. So that's more or less what we do. And you can imagine we have a lot of interfaces from and to the aircraft. We upload data to the aircraft, we download data from the aircraft, and therefore we have also a lot of safety regulations coming down from the aircraft. And also, as we are operating in several military bases, we have also a lot of security requirements. To our journey, we started our journey already in 2004 to 2005 with this project. At that time, with a classical waterfall approach, already incremental, iterative approach, but our normal iterations were about 1 to 2 years, let's say. So with this typical big upfront planning, analysis phases, and about 1.5 year of implementation phases, and then huge integration and testing phases because it's several nations, then they're putting all the software together with all the problems that are related with it in terms of quality, in terms of replanning, in terms of delay of your schedule, and so on and so on. So several years ago, we switched to feature-driven development. We still had this big upfront planning, more or less, for setting up the phases, because the phases itself were not shortened. But within, we did the design, development, testing per feature then. So it helped us a lot in terms of quality and also a little bit of predictability. But as we still had these long phases, the main problems were the same. And then about 5 years ago, we had to ramp up the team drastically, and we got from other projects teams that already applied Scrum. So we said, okay, well, when we are ramping up, let's also try this Scrum approach. So we switched to Scrum, started about 4 weeks iterations, roundabout 4-week sprints, and then went down to 2-week sprints over time. But we also had several problems related to Scrum. Were different per team. One was the team, for example, coming from feature-driven development. They just said, okay, we don't want to do this Scrum thing, and we had heavy resistance in the team and a really bad mood in this team. Other teams, there were more problems like we cannot hold our sprint commitments at all because of the customer. We were quite delayed at that time, and so we had a lot of pressure from the stakeholders with ever-changing priorities and so on. So it was quite heavy to hold the sprint commitments. So we said, okay, that Scrum approach works for us more or less, but we have several problems. Can we do a little bit better? And we did a little research and found out, okay, there's this Kanban thing going on, so let's try that. And we came up with our first Kanban board and first thing, and yeah, try to get started in this Kanban thing. Who of you knows Kanban already? Oh, okay, impressive. Who of you uses Kanban? Huh? Okay. Surprised? Okay, so let's talk a little about Kanban. I don't want to go into details, but what is Kanban? For most of the people I talk to, Kanban is just this board thing with the tickets. But Kanban is, for me, it's a change management method. So in traditional change management methods, you have a state A that you're in, and you want to improve. So you go to your offices, you collect all your management guys, and they do exhaustive documentation, prescribe your new roles, your new processes, and then at one time when you have everything ready, you roll out and install your new processes, you train the people, and you have your perfect state B, and then detect, okay, maybe it was not that perfect at all. Kanban has a complete different approach. So you're still starting at a state A, but you don't expect that there is a perfect state B. Instead, what you do, you try to improve incrementally. So you do a small change, check, measure, does it work? Maybe roll back, maybe roll forward, and you do change and change and change and change. And so it's a continuous journey that you try to improve. And this is also reflected in the Kanban principles. I just will go quickly through the principles that you get how we want to go, because I want to talk about the journey. So I have to go to the principles first. So the first two principles are start where you are and respect initial roles, processes, and job titles. So start where you are as the benefit of you can just start and you have to change nothing initially. And respect the initial roles, processes helps you also to install Kanban very easy, because you don't have this resistance and this fear for change. So the people don't resist, I don't want to do this, for example, what we had in the past with, oh, I don't want to do this Scrum thing because you steal my architect role or my manager role or whatever. So it's quite easy and don't have much resistance. So it's the first two principles. The second two principles: agree to pursue incremental evolutionary change. It's what more or less what I told in the slide before. Do these incremental evolutionary small changes. Encourage acts of leadership on all levels of your organization. What that basically means is create an atmosphere where fear has no place, where each individual in your team feels empowered to do changes themselves, so you can act really, really fast and react very, very fast. So, but how do you set up your first Kanban system then at all? Kanban has a Kanban system design, static, so system thinking approach to introducing Kanban, which is a method that helps you understand your customer. So understand, for example, his dissatisfactions, what is the source and nature of his demand coming from there. But you also look on your workflow, on your system, understand and try to visualize your process and understand what are your capabilities. And this is also an iterative approach. So if something changes, for example, your stakeholders changes, your customer changes, their requirements change, maybe they have a new priority or a new class of service that your Kanban system has to tackle, you just go through. But it's even not only the stakeholders, it's also your system. So maybe you change something internally in your system. I will come up later a little bit what that means. Then you go through this loop again and redefine your Kanban system. That your Kanban system is always fit for purpose. So fitness for purpose is quite important in Kanban. So what is fitness for purpose? Fitness for purpose is always something external. So just your customer, your stakeholder defines what makes your Kanban system, the service you deliver, fit for purpose. And to measure fitness for purpose, you have to define fitness criteria. And I will go a little bit through the fitness criteria we have defined for our system, which are basically derived from our Kanban system design, our static. So you get dissatisfactions from your customer that you can reflect directly, or requirements from your customer that you can directly translate to your fitness criteria. For example, we had quality, because we had kind of problems with our quality, because we had these long phases at the very beginning, so customer was really dissatisfied with the quality of the product at that time. Speed was another thing. Like you can imagine, if you have 2 years for a release, or even sometimes more, then this is also an issue for the customer, because if you define a new feature and he gets it 3 years later. Our third fitness criteria was predictability, or is predictability. This is not only from a completely customer point of view, but also internal management requirement that we had. So, but these are just our fitness criteria. If you define your Kanban system, you might have completely different fitness criteria. Let's imagine you have a startup, so quality maybe doesn't matter at all for a startup. Speed, at least not speed delivering value to your customer, maybe it's more the speed of learning, and maybe predictability doesn't even matter in your startup. So fitness criteria are really need to fit to your environment, and also they can evolve over time. As I said, if you change, your customers change, or the way you deliver change, then also your fitness criteria will change over time. And Kanban has a meeting called Service Delivery Review. We do this in a cadence of 3 weeks currently, and there what you do, you check your capability, for example, in terms of quality, the quality you can deliver, does fit towards the customer demand. So what kind of quality or what level of quality does the customer want from you, and what are you able to deliver? And in this service delivery review, you compare your capability to your to demand from the customer, and check if you perform to customer expectations. So coming back to our fitness criteria, the first one was quality. So as I said, it's always something externally from the customer. So what we defined is bug trend and customer problem reports. So how many customer problem reports do we get in a certain time? This was something that we measured. So if you improve the quality, you should get less customer problem reports. That's the measure that we did. As we had a lot of problems with our quality, we did also a lot of internally measured, which has nothing to do with the fitness criteria of quality from external point of view, which is, for example, if you measure the complexity of your software, your coverage, so the typical software metrics that you would also take. And we introduced a lot of things like TDD, like pair programming. We just do most of the work in pairs. We introduced refactoring and all this stuff to improve the quality over time. So that was quality. The next thing was speed. So what does speed mean? Speed is just how often, how much can you deliver value to the customer. And looking at your whole Kanban workflow that you have defined, Kanban gives you a really systematic approach to check if you're speeding up, or where are the problems in your system. We also have another word in Kanban called flow. And flow is, what is flow? Flow is the movement of your tickets over the board. So we are interested in this smooth and steady movement of the tickets. And if you don't have flow, you directly see this also on your board. Your tickets are piling up at a certain point, or the tickets don't move anymore. So that's the thing we measured. And we started our Kanban thing, which is, I think, quite typical, just with a software development team. So only the software development team started with Kanban, so our Kanban workflow was not so big. But still, we tried to have a look on the speed side, and what we detected, we are not so fast. And having a look on that, we found out that the problem for that was every developer was working on about 3 to 5 things at the same time. So our work in progress limit was quite high. And to see how we improved over time, I will show you a lot of such examples then, or different fitness criteria. What we did is just we reduced the work in progress limit, and that speeded up development a lot. What we did then, okay, development is more or less fine, so let's put the testers on board. We had a separate independent testing team at that time, and what we did, okay, let's expand the Kanban workflow, introduce the testers also there, gave them a complete separate column on the board, and let's see how we do. And what we found out was, let's imagine you develop a feature and it takes you 1 week, and then the testing team pulls it, and the testing team takes also around about 1 week for testing and doing a little bit of rework to have the feature done. But if you measure the complete cycle time, it takes 4 weeks to complete your feature. The reason for that was we finished the feature 1 week, 2 weeks nothing, waiting, 1 week testing. So the solution is also quite typical, and it's the logical consequence if you're aware of all this Scrum thing. You do first improve the collaboration between your testing and your development team, but we ended up in having a cross-functional team with testers and developers within, and so it's quite impressive that you speed up. You have doubled the speed or halved your system cycle time by just changing the way you work. After doing that, we said, okay, let's have a look on the complete workflow again on the Kanban workflow we have. And the next obvious thing we found was replenishment. So when do we take the next thing? At that time, what we did is as we have several customers, we had round about each half year a meeting with a customer, defining all, okay, this is the new feature, how we will build it, everything is defined. And then it took about half a year till we started it, to build it. So, and that's really the point where you start talking with your customer and involve the customer and say to the customer, okay, we have to change something. It just waits half a year till we start it. And it was not so easy to do this discussion with a customer because, as I said in the beginning, it's several nations that have to come together. We at the end managed to nail it down to about 1 or 2 months to get everyone together. So, but still, it's a significant reduction from 6 months to 1 or 2 months from defining your feature till you start working on it. Internally, we did something completely different to increase the frequency even more. So we have this one column where we say this is ready to be pulled features or backlog items with a work in progress limit of, let's say, 3. And if there are 3 tickets in, everything nice and shiny. And as soon as something is pulled into the system, we have only 2 tickets with a limit on 3 with this column. This gives us a trigger that we have to replenish 1 more item. And that's really what we do. We replenish item per item with just this trigger. So we defer the commitment at the latest possible point where you have the most of the knowledge. And it also provides you a very, very easy way to do fast changes. You don't have to say, okay, we just work on this weekend or this next 2 weeks on this and this and this, but you can just decide if one slot is open, you have one new Kanban, you just replenish. It makes you very, very fast to react to changes. And it's also easy to tell someone, okay, you have to just wait 1 more day and then we can replenish exactly what you want. Going back to the Kanban workflow, we said, okay, delivery is also another point we have problems. For example, we had a problem with the performance of our application. When we were processing big amount of data, we had massive startup problems with the application. So it took minutes for the application to start up. And it just occurred on customer side. We had just delivered a new version. And we were able, with the customer together, to solve this problem within 1 or 2 weeks. No problem. The problem was that our next delivery was 1 year ahead. Until the customer received the fix, it was 1 year. And with the customer knowing that we already have fixed it 1 year ago. So this is also, then you go to the customer, discuss with your customer again, okay, we have to do something about that. The problem is that, as I said you before, we have also all these safety and security regulations, and you cannot just deliver a new version. You have to go all through this safety and security audits, which takes time. So we managed to reduce this time from 1 year to half a year. But we built us another small workaround that we can just prove that we haven't touched security or safety critical functions and can deliver patches, monthly patches in between. So it's far from perfect, but at least we managed to reduce the time from 1 year to a month, which is a really big step in such projects. So this was speed, the second fitness criteria we defined. The third fitness criteria was predictability. What is predictability? Predictability is the degree to which a correct prediction or forecast of a system state can be made. Clear? Huh? No. Predictability tells us we have to tell something about the future. For example, when do we deliver a feature? When do we deliver the next few features? And you have different stakeholders for different types of predictability. So one could be your external stakeholders, your customers. that is interested. When do I get feature X, Y, or when do I get the next 5 features? But you also have internal stakeholders in terms of your project management, for example, that wants to know, okay, how many resources will I need? How much does it cost? How do I do the controlling? Do we, for example, make or buy something, and so on. So they also need predictability. So the stakeholders have a big influence on the predictability of your systems also. For example, when we first delivered our software to the customer, what we normally do, then we agree some service level agreements with them. Service level agreements, SLAs, are just, okay, if you have a problem, customer, and it's a quite critical problem, you can say it's a customer problem report with priority 1, we have to react in a day, priority 2, we have to react in a week, priority 3 in a month, and so on. The problem at that point in time was that we had a lot of priority 1s, and we were not able to react in the correct time. If we just had put it on a normal Kanban system, and it would have waited, it would have taken too long. What you normally do is then in Kanban, you just introduce a new swim lane. So we've introduced a new express lane, expedite lane, and whenever we get a problem report from the customer, we were just swarming on this and to get it fast through. And that externally solved our problem. We were able to really get the problem reports from the customer side tackled in the correct time frame. What's nice. The problem is you get a problem with your predictability. So whenever, imagine you have the standard lane, and you measure your cycle time, your standard lane, everything is nice. Whenever a customer problem report comes, you just stop working on your standard lane. So it makes it somehow unpredictable. What we did is we introduced some slack into the system. What does slack mean? Yeah, well, it's in the Kanban system, it's quite easy. It's always a good solution in Kanban, putting another lane. So we introduced another lane, an intangible lane. And in this tangible lane, we said, okay, we will, from our resources, we allocate 10 to 20% are just doing quality invests. Because we have some quality issues on this intangible lane, we just do quality invests. That is nothing adding direct value to the customer, but for 10 or 20% resources, we just invest there. So whenever you get now a customer problem report, you can just take 10 to 20% of your resources and allocate them to the customer problem report without disturbing your standard lane. So your standard lane is still predictable. And that was a really, really good way to improve our predictability at that time. Other things that impact the predictability of your systems are if your system is stable. What do I mean with stable? Stable system is, okay, for example, you have the same amount of people working in a team. As soon as you lose a lot of people or you add a lot of people, your system will somehow get unstable, at least for a while. And so it doesn't make it's hard to do estimates or forecasts if you have a lot of changes in your Kanban system. So you always try to have a stable system to be predictable. The other point is we're in a software development world. We're living in a complex domain world. I'm talking about Kinefin framework. I think we have heard it in several other talks already today. So we're living in a complex domain world, and we have a lot of uncertainty, a lot of unknowns, and so on. And we tried a lot of different estimation methods in the past, from expert guesses to team estimates to story points to function point to COCOMO analysis. So nearly everything, but nothing really worked good for us till we understood, okay, we are not living in this complicated world. We are living in a complex domain world. And to tackle this kind of problems in a complex domain world, for example, you have a stable system. then Monte Carlo simulations are a really, really good mean to tackle this, and that's exactly what we did. We're just doing our forecasts using Monte Carlo simulations nowadays. We don't do any estimates at all. And I don't want to go to the complete math now of Monte Carlo simulations, but just give you a rough overview of what a Monte Carlo simulation is. Basically, you define your model first. For example, you have an input of your historical cycle time. Then you say, okay, that's the work I want to do for the next release, and you add an additional input, at least for our model is here, your historical scope creep or your failure load. And what you do then, you take your historical cycle time, split it in two, create your baseline with the first part of your historical cycle time data, and then validate your model against the second part. And if this works out, then you have something valid to do forecasts for the future, always expecting that your system is stable and stays stable. And what we get out is kind of such things. You get a distribution of possibilities when you will finish the project. For example, here it's more or less 19 days, and you get things like with a chance of 85%, you will finish your project or your projected delivery date is Thursday, September the 28th, which is luckily today. So I hope we will finish sometime. Or you can get out forecast delivery date trends. So what we do is we do, for example, a Monte Carlo simulation at day 1, day 2, day 3, day 4, day 5, and then you get a trend of your projected delivery date, which should be normally it's just a line. You see here it's going slightly up. This is historical data from last year, so a real forecast that we did, and you see it's going up. And we have defined policies. If we have, for example, 5 ups in a row, then something is wrong. Now we go back, okay, and then that's the point where you get a really, really fast indication if you have a problem with your delivery date. This was actually a problem in our model at that time. So what we had just, these are the features we want to do, and this is our historical cycle time data, but we haven't added something like our historical scope creep. You always add during your iteration some new backlog items, and we added this to the model, and now it's a lot better. But at that time, that was exactly the problem. But it could also be something that this system is not stable anymore. For example, you lose your database expert, you're joining your development and your testing team, something changes, and it will directly show up in your delivery date trend. So how do we do the forecasts? We normally have an output something like this. Imagine you have feature 1 with 2 items remaining, your 85th percentile of chance to deliver it or to complete it is the 5th of July, and the completion likelihood for your release is 93% in this case. And then you just say feature by feature by feature, running your forecast, and can say, okay, the possibility is quite high that you deliver these 2 features. It's kind of likely, it's 65% here to deliver the next 2 features, but we have a problem with these 2 features. And this gives you a very, very easy way to say, okay, we have to do something. Maybe you have to groom your backlog, reorder your features, whatever you do, and you just run your Monte Carlo simulation again and have a new result there. So this Monte Carlo forecasting drastically increased the accuracy of our estimates, and it also massively reduced the effort it took to get to an estimate. Before, we had about 15% of our whole time spent in doing project plans, estimation, backlog grooming, re-estimation, replanning, re-estimation, updating the project plan again, and so on and so on. So now it's just just nothing in effort. So I want to come to a conclusion to sum up. So what has changed in total since we introduced Kanban? I've shown you how we apply Kanban at Airbus, how we defined our fitness criteria, how we evolved over time with the help of Kanban, how we improved the quality, how we speed it up. We are now able to deliver much, much more and often value to the customer. We can do forecasts and planning with nearly no effort. It's just a click. And that's all nice. But the more important thing for me is we have really a stressless and creative environment now. We have a happy customer again, and it's really, really fun to work with them. And we have also really, really, really much fun working now. But really the most important thing for me is it's the cultural change we have now. Now you're seeing, okay, we have really this new atmosphere. The people want to improve. They want to collaborate. This collaboration thingy is improving drastically, and it's just going on and on and on. Kanban is an evolutionary change method, and we just started our journey to Kanban land. And we evolve every single day. We want to get better and improve. That's really, really nice. So maybe you can also start your Kanban implementation, your Kanban system, define your fitness criteria, and evolve over time. Because I think the world is always changing faster and faster. And it has never moved that fast that it does now, and it will never, ever move that slowly again. And Kanban can help you to be fit for purpose also for tomorrow's world. Thank you.